Tonight is November the 27th, 2014, Thanksgiving Day. I want to thank all of the YouTube viewers for all of your suggestions. They have helped immensely, and I think are going to lead to the solution of this very small high frequency anomaly that keeps this old amp from meeting its full specs. Okay, it's completely normal right now. I've tinkered with it here and there. It's got the 7581s, KT66s as they call them, good USA tubes made by GE for the outputs. It's got the Mullard 10M series tubes, 12AX, 12AU, 12AX under there, RCA 12AU7, same as it was on the other one. Essentially nothing has been changed. Now what I have learned is mine is this old schematic right here, where it has one of the things has a 30K there and a 27K. And here's a nice copy with all the notes in it. And if you look at all the notes, pretty much everything changed with serial number 428L7. They basically took out all of these little parasitic stoppers, like right here. See, this one has a 100 picofarad cap in it. Well, take that one actually is missing. That one has been removed. That one did, by removing that 100 picofarad capacitor off the plate of this 12AU7 to ground, did improve the high frequency response. See, this tube right here is running a grounded grid, because see, it's got a 0.22 grounding in it. It's got nothing to do with what I'm working on, but anyway, that one has been removed. Everything else is the same. I experimented with some different feedback resistors. If you increase the feedback, you actually get a better high frequency response in a way, but it ends up dropping off just about a half a decibel. Anyway, it's back to normal. This is the old one. The newer version removes all of these things. See the little dotted line there? Removed there. Removed all these little, as I call them, parasitic stoppers. This one, I don't remember. It's all in the notes. Anyway, if you fast forward over to, say, like this amp. This is an MC275. It's really the same circuit. They put a 1.8 picofarad up there, and they take all that other stuff out. See, there's none down here. Still got the same 330 picofarad feedback, 2.7K. They changed this ever so slightly in this area. But essentially, what they do is here in the power supply, that's where the big change comes in. See, there's a 10K, 100K, and then there's a voltage divider one here, 100K to ground. Well, they take that one out, that 100K, change this one to 150K. And then they change these two resistors from 30 and 27K to 56K and 51K. But they're also, then they change this voltage to 470 volts that they're running these on. Whereas these, this 30 and 27K are actually run off of 300 and, I guess it's 380. Well, I went and changed these two resistors without doing all this, and it went zonkers on me. So what I'm going to do is document exactly what it is now. It's running as I speak, and except something happened to it, I'll have to start that over. I'm not showing you that yet. I'll show you and document, post exactly how it's performing now. But what I'm going to do is I'm going to update this amp to this amp, and hope that I'm not missing some. I'm not sure, but I think there is a part number difference between this output transformer and this one. This is the one I have right here. I'm going to think about that a little bit. But anyway, I believe if I update everything else in here, it's probably going to get better, because this, like I say, keeps evolving into this. I think this is probably pretty much the last version of it. And they got all that nonsense out. There's one channel, there's the other channel. They're duplicates, of course. If you look at the circuit, they're all just almost exactly the same. 18Ks over here, 12K 2 watts there. Of course, the same 12A. They use a 12A Z7, but you can put in a 12A T7 if you want. Possibly even a 12A X7. The Z, the T, and the X are all considered high mu triodes. Same 12BH7, 12AU7, 12AX7. So there you go. That's what I'm going to do. And I'll do it in such a manner that if things really go to hell, I can back out of it. So let me, maybe I bumped it or something. Yeah, it looks like it went off here. This darn switch right here is bad. Somebody put that in there, and I bet that thing's opened up again. Anyway, I got to fix it and run it, and I'll show you the documentation. I'm going to run frequency response in THD, and that'll be the documentation before the change, and then I'll make the changes, and we'll see how that works. Okay, this is going to be the documentation for myself included. First, let's go to this one. This is THD, and I get this consistently. Little anomalies like this right here are just part of the program, so we can ignore that and these little bumps. But see, here's the problem. Here's what I'm working on. It's up, actually the last point plotted is right here. This is its last here's its last frequency, and it's THD. So at 25 kilohertz it's 0.92%. But even at 20 kilohertz right here, it's about the same. This is what I'm working on. So, you know, it's not like a major problem that can be seen on an oscilloscope. Without these instruments that I'm using here, I would never see this, and I'm not going to hear it either, and I know that. But I want to see it meet its specs. Okay, this is its THD. See right up there, that's what they call that. And the one behind it, the other one that I've run that is part of its documentation, is its frequency response. It looks like it's down about a half a decibel, a little bit less than one half a decibel at 25. Well, there it is right there, 0.43 dB at 25 kilohertz. So its frequency response is excellent. And these numbers agree with static conditions when I measure it at particular frequencies. They completely agree. These graphs are actually marvelous. They have some of the slightest anomalies in them like that right there, but they're free and written by Mr. Pete Millett. Thanks, Pete. And overall they do a marvelous job. So this is it. This right here I have no problem with. Now, if I change the feedback capacitor from 330 picofarads, if I raise it, this gets worse, if you want to call it. It'll drop down to 1.5 dB. So the slope will come across here and drop down to here at these real high frequencies as far as frequency response goes, with more feedback. And this will get much less. It'll end up pretty much, I think it ends up at about 0.63 consistently. So this will drop down 0.3 of a dB. Or, yeah. So there's a trade-off there, but that's not the right way to look at it. So this is what it is. I'm going to make those changes, and then I'll run these very same ones again, 20 hertz to 30 kilohertz, 10 points per decade. Let's see if it works. If it doesn't, well, like I say, I'll do it in such a manner that I can back out if need be. I got to get to work. It is November the 28th, 2014, and I have concluded this project. It's turned out very nice. I'll show you what I did. I did as I said I was going to do, and I changed it over from this old design right here. See, the serial number of mine is 240L8. 240 L8, and if you look at where things changed over, everything changed over at 428 L7, so mine's pretty old, which is fine. But there were quite a few differences, and I made this circuit, just like I talked about I was going to do. I did have to add that one little 15 picofarad parasitic stopper. If you read all the notes, what they did is they took out this 100 picofarad. At one time they apparently added some in up here. That one is still there. It's a 330 picofarad. I checked all the resistors; they're all well in tolerance. Everything's. Oh, the power supply was a big difference. This resistor is now missing. See, the way it was right here, I think I pointed this out already. There was a dropping resistor here, so they ran 380 volts up to this 30K and 27K. Well, if they run the 56K and 51K, they jump right out and run it at 470 volts. So it's turned out real nice. I'll show you what it looks like. Here it is. Here's the new big capacitors in it. What was in it initially was 150 microfarads. That's in the voltage doubler. Those are 470 at 450 volts, so they should last. The power supply, see, I changed that 100K to the 150K. There's that 10K, but it's, I don't know if you can see it. I try to keep the light down, it helps to glare. I've got it jumpered. I may snip it out later. I took out 100 picofarad over here. I added that little guy right there. That's the 15 picofarad I just showed you in the schematic. And everything else pretty much the same. I added 6 amp diodes instead of the little ones that were in there. An unfortunate thing happened, and that is somehow in the working on it I bumped this little parasitic choke right here, that little plate choke, and opened it up. I broke the wire on it, and when I did that, it removed a plate voltage from this tube right here. And I had my new Tungsol KT66s in there, and it just smoked the hell out of them, because I ended up with screen voltage but no plate voltage, and you can't do that. So it destroyed them. That was one loss. Another thing I did by complete accident, this has got the same tubes in it, is I'll discuss this tube right here in just a second, but I accidentally put a 12A U7 in there. Don't do that, because what it'll do, and you'll end up in there troubleshooting it. See that minus 52 volts right there? It'll end up dropping about 26 if you put a 12A U7 in here. It wants a high mu tube. 12AX7, 12AT7, 12AZ7. Okay, now I'll go there. If you look over here, they use a 12AZ7 or a 12AT. Those are the 3 high mu triodes. The 12AU, 12BH7, 6DJ8, etc., 6BQ7A. Those are all medium gain triodes. And what really made a significant difference in this one is changing this, just putting in a 12AZ7 or a 12AT7. I'm going to turn it over. I'm going to put the bottom on to eliminate all the noise I can, and I'll show you. It works here. I just scanned it again, and there's where it starts out. Down here at about 0.2 THD at 20 hertz, and it's it's actually 0.53 at 25 kilohertz. The 20 kilohertz line is right there, so it's 0.4. I'll show you what it used to be. Let's see, my project here. Oh goodness, let's see, before repair, before change. Yeah, see how bad it was? It was up here at almost to 1%, 0.9. It just wasn't doing real well. So that's what I was working on right there. Nothing you're ever going to see with just an oscilloscope, but this is what I get now consistently. And I'll run it for you and show you. I'm running at 20 hertz to 30 kilohertz. I only have to run it to 20 to make it meet its specs. And I'll run it again real time so you can see. Let's see. There's another thing I wanted to mention that I ran across, and that is some of these amps right here in the MC40s say that you can run 7027s. Well, you better be really, really careful. You better know what you're doing before you plug a 7027 in there. I wish I'd have got this book out. Be a little bit more organized here, but I got to show you something. On a 6L6, pins 1 and 6 are not used. So they are just almost always used for tie points. But on a 7027, look at this. If you look at pin 1, you see it's also connected to the screen. There's a dual connection to the screen, pin 1 and pin 4. On 6L6, it's just pin 4. Same thing with the control grid. The control grid on a 6L6 is just on pin 5. But on a 7027, it's also on pin 6. So the point being is that if you use 6L6s and you want to go to 7027s, you can't be using pin 1 and pin 6 of the tube socket as tie points, or you're going to be really sorry when you plug that thing in. And you can see right here, here's pin 5, that's the control grid. They use pin 6. Right here is just a tie point, it's just like a terminal strip point. Actually, this is the plate load resistor for this tube, and this is the plate load resistor for the other half of that tube. Now, pin 1 normally was open. I grounded it. One side of the filament line is grounded, so I grounded pin 1, and I did the same thing there, just because I didn't want it floating. On the metal tubes like 6550s that have the metal ring on the base, the metal ring is connected to pin 1 and should be grounded in case something shorts somewhere. You want to end up with high voltage on your metal ring. But I thought I should point that out. A 6L6, let's see, here's some. This is also a 6L6. It's a 7581, if you can read that. Also known as a KT66. It's got both of those stamped on there. These tubes do extremely well. There it is, 7581A KT66. This is a 6L6. And so you can see pin 1 and pin 6 are missing. Right there's 1 and 6. They're missing. So you can use 1 and 6 on the tube socket for terminal strips, but that's not true on a 7027. You can plug a 7027 in there if and only if you're not using those pins. So the best way to know is either, I guess the manual would tell you so, or you can look at it. I just thought I'd warn you about that because I see that a lot. Oh, I added another thing in here too. I added the thermal resistor, so that it limits the current on power up. I'm gonna have to stop this thing, put the cover on it, and I'll run it once and show you. I'm real happy with it, and I appreciate all of the help I got from YouTube. See, I don't think there's anything else. See, the capacitors are all the same. The electrolytics, those little electrolytics there, this one down here, were changed. I think I've already pointed that out. But I'm not much for modding amplifiers. I prefer to leave them as stock as I possibly can. Let me get it back over, get the bottom on, and we'll spin it up and move on. Okay, got it back together. Got the same tubes in it, except for this 12AZ7. Now, I want to show you. you might be concerned about those big capacitors. They're 470 microfarads instead of 150. But that thermistor, I'm going to flip this thing on right here and watch the current. See, it goes up to 1 amp. Never exceeds 1 amp. Damn glare. Sorry. So it does its job, so that when you power it up, it doesn't, exceed an enormous amount of current from the line, powering up and charging those big caps. I think I got everything. I tried. See, here's my 12AZ7s I put in there. I tried different tubes, as everybody suggested, and they all work the same. Once I moved to the 12AZ7 and the 12AT7, I think the Z worked slightly better. I tried these 70 or 5751s. Those are 12EX7. They work fine. More 12BH7s. More of these little Mullards. And on and on. So I've tried them all. For all practical purposes, the tubes perform the same. Difference is so small that I'm not sure that it's even repeatable. The same thing with these 5881s and these, and then whatever these things are called, I never can remember them. These 70 something and others. 7581s. They all perform the same. I don't remember which one I tested it with first time. Well, anyway, let's see what it does. Run two things here. THD, I believe it's all going to be set up. We'll put it at 10, and well, I've showed you what it does. Let's limit it to 20,000, just to make it a little quicker. Start. There's 17.89 volts. Would be exactly 40 watts. I can't get it dead set, but that's 40 watts right there. That's square divided by 8, so there it is. Reference level okay. Let's hope that the program doesn't do something really weird. Sometimes it starts out doing kinky things. Nope, it's turned out good. 20 hertz, starts out at 0.2. See, there's 0.5 right there. So our down glare. Let me shut the door. Maybe that'll help me. It's a beautiful day here in El Paso. Look at that sunshine. It's a good reason to stay here. Alright, now we're in the dark. But we'll let this thing run. And then the other one that I used, that I didn't see any difference in, was frequency response. This note here called FR. Let me show you it running. See, look at that THD. That at 0.1, 0.08 at a kilohertz. Marvelous. It's doing marvelous. There it is running. There's our voltage. Stays nice and steady. There's our frequency. You can see all that over there. There's a harmonics dancing across the spectrum analyzer. There's the output of the audio analyzer. This is the era. These are all the sum of all the harmonics. Okay, it just quit. It just finished. Look at that. 20 kilohertz, 0.4. Worked. Hallelujah. Now let's do frequency response. Uh-oh, my wife's home. Now I'm in trouble. 20,000. 20,000. Sorry for the fumbling. That's the 10, and it'll do it at the same power level. It'll show us the 17.44. Yes. Let me turn the intercom off. Sorry for having all these interruptions. Kind of like living here, huh? And there it comes across. You won't see anything until the very end. Also, I finally discovered and started using, you don't have to start at 20 hertz. You can put the start frequency at anything you want and end it at anything you want, right there, and right there. so you don't have to watch this thing scan the whole thing every time. Should have scanned it past 20 kilohertz, because it's just going to draw a straight line. I think it's down about a half a decibel, 0.4 decibels or so at 25 kilohertz. But I'll do a short scan here in a minute, as soon as this one finishes, so we don't interrupt it right in the middle. Actually, we can, it says it's down 0.29 decibels at 0.44 decibels at 20 kilohertz. There it is right there. You can see it dropped off ever so slightly. Let's stop this one, go back to frequency response again, and let's just scan it from 10,000, and we'll scan it all the way up to 100,000 at 10. Start. Still at our 40 watt level. Got to do everything at the highest level. See where there's 0 right there, this line. And we'll see it come across. There's 10, 20 kilohertz, 30, 40, 50 kilohertz is down 1.29 decibels, 63, 178, 80, 2.5, 3.5 at 100 kilohertz. So it's half power at 100 kilohertz, a little bit less than half power at 100 kilohertz. Doing great. Real pleased with it. And once again, thank you so much for all of the help, the advice, the encouragement, and just can't have enough fun here. Hope you enjoyed, and we'll see what's next. Well, I did pick up one thing here I want to show you. I have to turn this darn thing off. This fluorescent light does weird things to it. I picked this guy up right here just recently off of eBay for 20 bucks. Really, really nice. I've used this for ages, but this does not give a flat response. This is some sort of a telephone device, which is quite nice for an attenuator. Really, you know, works. But it only works mostly in the kilohertz to 5 kilohertz range. This guy's flat, and it actually is, from DC to a megahertz. I highly recommend this thing, and it is just spot on accurate. Just bullseye. I love it. I got it so cheap because it didn't have the case, but I'm going to build it a little case. But you might like that. And I have scanned it, and it is flat. It really is the 20 to 100 kilohertz that I can scan it at. And one other project I'm working on that I'll post when I get it done is this Marshall amp down here for the musicians in the family. I'm doing a few mods on it for the client. There you go. Having more fun every day. Can't get enough.